Gude and welcome to my video Unlock AI Superpowers, Boost Performance with NVIDIA CUDA. This title has been suggested by ChatGPT to boost or to gain attention. So if you are watching this video right now, ChatGPT seems to be right. So thank you, ChatGPT. Okay, if you are familiar with AI or machine learning, you probably will know that using GPU power is better than using pure CPU usage. In this video, you can expect a short introduction about what is NVIDIA CUDA, which graphic cards are supported by CUDA, how much faster is using GPU CUDA over pure CPU usage. Obviously, I will show you how you install CUDA on Windows, and please let me know in the comments if I should make a tutorial on Linux. I will create a Python virtual environment using the famous library Pytorch with enabled CUDA support. And finally, as being a voice enthusiast, I will do a direct performance comparison using Coqui text-to-speech with CUDA, GPU and CPU performance. And before we start, important is give this video a like if you like it, subscribe to my channel if you like my content in general, and let me know on what you think. And talking about feedback, I don't know if you have already seen it, but I'm recording in a completely new setup. It feels a little bit unreal by now, but please let me know what you think on new background and recording setup. And talking about the new setup, I would like to give a big thank you and shout out to my dear friend Mighty Righty for his inspiration and support on building this new setup. So thanks a lot, Mighty Righty. And before we hop on to my Windows machine, here's just a brief introduction about what is CUDA, or Compute Unified Device Architecture. It's an API developed by NVIDIA in the year 2007, so way before this huge AI hype has started. And by today it's available in version 12.5 and supported on Windows and Linux. And CUDA enables developers to use the benefits of direct GPU power usage with parallel computing in their own applications. And it's commonly used in Python and data science and large-scale data processing tasks. And we will use this famous Python-based library called Pytorch in this video. Okay, I guess that's all for the introduction, and now let's start with the actual cool part. Let's start taking a look to which graphic cards are supported by CUDA. CUDA is just, at least in my opinion, supported by NVIDIA graphic cards. Please let me know in the comments if I'm wrong on that. I guess there has been projects trying to adopt CUDA to other graphic cards, but this did not really work out. But please correct me if I'm wrong on that. So mainly NVIDIA graphic cards are supported. I'm using an older graphic card, an NVIDIA GeForce 1050 on my Windows PC here. And you can see on this web page, I'll put all the links in the description box below, which graphic cards are supported by CUDA. And you can see lots of categories, so the famous GeForce consumer graphic card products, or this enabled Jetson products. So let's see if I know that my 1050 is supported, but I will show you how you can find out. So let's see the GeForce category here and search for 1050 in my case. You can see that my older graphic card is supported by CUDA. If your graphic card is way older and you cannot see them in this list, there's a link to the legacy GPU CUDA supported page. You can hit that link again in the description box below, and you can see older NVIDIA graphic cards that are nevertheless supported by CUDA. And if you know that your graphic card is supported by CUDA, how much faster can AI or machine learning or processing in general be over CPU usage? There are tons of articles and comparisons comparing CPU versus GPU versus CUDA. I've chosen randomly one. In this article, it's using TensorFlow, which is another famous framework, I guess, developed by Google for machine learning tasks. So even if I'm using PyTorch in this video, this should show the performance comparison. So let's go down a little bit and you can see training a network using CPU here. It's taking about 480 seconds per epoch and 3 seconds per training step. So that's the value on CPU. And let's go to the GPU here. You can see 75 seconds for the complete epoch or 0.5 seconds per step. So this is resulting in 85% less training time. And I guess that's a huge improvement. So if you know your graphic card is supported and you know that it's worth the effort to install CUDA because the performance is significant way better than CPU, it's time to install CUDA. So for that, let's go to the CUDA download page and you have to choose your operating system. But before you start the download, keep one thing in mind. At least in my case, I'm using Python with Pytorch. And we have to check first which CUDA version is supported by which Pytorch version. Whoa, complex phrase. So for that, I will start by taking a look to the installation guide of Pytorch. I've chosen to use the stable release, which is version 2.3.0 on Windows using the Python package management. And as you can see here already, CUDA 11.8 and CUDA 12.1 is supported. CUDA 12.4 is grayed out or whatever, not supported. If you enable the preview, the nightly build, there's a support for CUDA 12.4, but 12.5 is not listed here at all. I will stay with the stable branch and would like to go with CUDA 12.1. So let's go back to the download page and you can see 12.5 too new for the Pytorch version, for the stable Pytorch version. So I will go to this link here to the archive, let me know, of previous CUDA releases. Let's go here and go for version 12.1 or 12.1.1 in this case and download this release for Windows 10 in my case, downloader or installer. As you can see, it's over 3 gigabytes of download size, so it might take, depending on your internet connection, a little bit. So hit download. I can cancel this download because I've already downloaded CUDA. And before I will start the installer or the install process, I will go to my installed programs on Windows and search for CUDA. And here you can see I've already installed CUDA version 11.7 and 12.1. If you have no CUDA installation by now, this list in your case should be empty when you filter to CUDA. So let's start the installer in the download folder. Downloads. Sorry, let's cancel the additional download and just run the previously downloaded installer. System compatibility is checked. Now you can agree the license agreements or accept the license agreements and you can run the installer. I will skip this process as I've already installed this specific version of CUDA on my Windows system, but I guess you will find your way through the installer. So let's cancel this. And now let's create a Python virtual environment with that famous machine learning library Pytorch. And to do a comparison, I will do one Python virtual environment without with Pytorch without CUDA support. That's it. And another Python virtual environment with Pytorch with CUDA support. That's what I try to do. So for that, let's open a command prompt or a PowerShell prompt or whatever you prefer. Let's first of all create a new folder for our first test. Let's create CUDA 1. Let's move in. I've installed Python version 3.10 on my system, which is supported later on for Coqui TTS for our comparison. So I will use this Python version to create a virtual environment. Let's make it visible. Once created, let's activate this venv by running venv scripts activate.ps1 for the PowerShell command line prompt, or batch for the classical Windows command line prompt. And I'm inside my virtual environment. Let's run pip list, see the list of installed packages here. And we can see that we have just pip, so the package management and setup tools. And there's an update available for the package management itself. I would recommend you to install this update by running this command. Now we have the newest version of the package management. And now I would like to install Pytorch from the classic repository, so no special CUDA parameters or whatever. So by running pip install Pytorch, which might take a second or not. What's missing? What's the problem? You try to install Pytorch, the package name is Torch. Okay, this is some way embarrassing for me. So, okay, then let's install it with the right package name by running pip install torch. Needless to say, I knew this before, but I would like to show you that errors are normal. Some way. So once you install Pytorch, by installing the package torch, and the process is finished, we can run pip list. Where's the focus? Pip list to see if Torch is installed, and here we are. Torch is installed in version 2.3.1 without any indicator on CUDA support. So to see in Python or Python virtual, in a Python German bug, in a Python virtual environment, if Torch with CUDA support is supported, I've created a small script. Okay, let's be honest, I've taken a snippet from Stack Overflow, link in the description box, to test CUDA support on Python. So let's give our script a look. Test CUDA. Let's take a look with Notepad. And here you can see we import the Torch package and print 3 informations to CUDA, whether it is available in general. If you have more than one GPU, so more than one graphic card, you can get the number of graphic cards installed and supported, and you can get a specific name of a specific or the name of a specific CUDA GPU graphic card. So let's take this script and go back to our command line prompt. The script is one level up, so it's in this base folder, and let's run Python. This is still version 3.10.11. Let's run Python with the test CUDA script, but we are still inside our Python virtual environment with the Torch package without CUDA support enabled. Let's run it. And as you can see by this error message here, Torch is not compiled with CUDA enabled. And that's expected because we installed just a simple Python Torch package without CUDA. And now let's leave this Python virtual environment. Let's create a new one and install Pytorch with CUDA support. So let's run deactivate. As you can see by the prefix now, we are outside our Python virtual environment. let's create a new folder, make it CUDA 2, and go into CUDA 2. Let's again install a Python virtual environment. Finished. Let's activate this one. VN scripts activate PowerShell script. We're now inside again the virtual environment. Maybe it would be smarter to give the venv a special name for each directory. Not both venv, but hopefully you can follow. So this venv now is inside our newly set up Python virtual environment. And again, let's update our package management. And now we won't install Pytorch with a default Torch package, but instead let's go back to our browser, to the download page of Pytorch, and let's choose CUDA 12.1, which has been the version we installed. And let's copy this command. Copy, and as you can see, this is running the pip, Python package management install, with a specific Pytorch repository for this CUDA support. And let's run this. Installation of Torch package is finished. Let's see our pip list, our well-known pip list. And now you can see that we do not just have Torch installed in version 2.3.1, but with that addition of CUDA 12.1. So this is the difference between running just pip install Torch and running the command here from the Pytorch website. So, and now, as we did previously, let's go one level up and let's run the test CUDA scriptlet taken from Stack Overflow again. Test CUDA. And here we are. So now we can see that these three prints, let's open the script here to see if CUDA is available in general, how many graphic cards are detected, and get the name of graphic card number 1, or the first graphic card, is replied by yes, CUDA is supported, 1 graphic card found, and this is my 1050 graphic card. Now inside this Python virtual environment, you are able to do high-performant CUDA-enabled machine learning actions and scripts and data analysis, more performant than just with CPU only. And now let's do a voice performance comparison. So you install Coqui TTS inside of this CUDA-enabled Torch Python virtual environment and run speech synthesis with CPU and with CUDA and see how it performs against each other. So for that, let's simply install TTS and in addition some default packages like setup tools and wheel minus upgrade. Wow, this took really a long time. I could really watch some YouTube shorts in the meantime. But nevertheless, we are done. Let's see our pip list, and then we should have Coqui TTS package installed. Here we are, TTS in version 0.22, German bug, 22.0. And now let's synthesize an English phrase with an English model, obviously, one time with CUDA and one time without CUDA, and see our RTF, so our real-time factor value, and the time it took in total to synthesize this phrase on CPU and on GPU. Let's first of all choose a random English model. This is the list of all available TTS and voice encoder models. So let's choose the English LJ speech-based WITS model. This has already been downloaded. So this is the model name. Let's run TTS model name, paste the model name, text, this phrase is a demo sentence to check if performance using CUDA, so GPU based usage is faster than using pure CPU power. And let's set the out path. Take test no CUDA wave. If I do not specify my use underscore CUDA, it will by default use CPU power. And just to see the performance, let's open our task manager in parallel. No, where's the performance? Here we are. Let's move this here. And let's see. So we should see the CPU should go high and the GPU down here should stay low. In general, at the beginning, it will always consume a little bit of CPU time to load the actual model. Before the text-to-speech synthesis is done, the model has to be loaded into the memory and whatever. So let's run this command and see the CPU load. So CPU is going high. Not sure where my command prompt is, but you can see CPU is 100%. And it's going. It's down now. See the directory. So we have this file test no CUDA wave. Synthesized, but what's missing is my output. So where is my output gone? This is interesting. Normally I would here, interesting. So do not ask me why Windows is putting this output randomly in the middle of whatever. But nevertheless, we have this demo phrase here, and processing time in total, so 7.48 seconds were required to synthesize this audio phrase, which is a real-time factor of 0.68, so a little bit faster than real-time using CPU. Let's simply save this value for comparison. Put it here, and I will do another test just to see if there's no caching or whatever going on. So if you have comparable values, this is looking weird. So let's call it test 2 and hope we can see more output than in our first try. So see CPU going high, 30%. Here's my output. So CPU is at 100% by now. And here we are. So we have a processing time now of 6.4 and a real-time factor of 0.6. Let's save this again. So small difference on the absolute time, but the real-time factor seems to be comparable. So now let's do this again with our test with CUDA, and we have to add the option use underscore CUDA true for that, and then we should see that the GPU is now used too. So let's keep an eye on our Task Manager. GPU right now is 1%, so not really active. CPU is at 30% because the model at the beginning, as I've said, is going to be loaded, and the GPU should go higher. Okay, 100%, so it has been a little bit higher for a short amount of time, and you can see that there's a absolute time of 2.3 seconds, which is way faster than the CPU only way, and the real-time factor additional is way less too. Yeah, that's the word I'm looking for. So this is our CPU only, and that's the GPU value, so way faster. And let's again do another test just to see if there's no caching or magic happening to be more performant. Task Manager. GPU is used for a really short amount of time, and again we have this value which is comparable to the last test. Okay, maybe we should listen to our sample.
This phrase is a demo sentence to check if performance using CUDA. So GPU-based usage is faster than using pure CPU power.
I hope you liked this video. If it is so, please give it a thumb up. Subscribe to my channel if you like my content in general. Share my channel with other voice technology enthusiasts. And yeah, if you like, we might see us next time. Bye.